Hi everyone, my name is Niku, and today I want to present you the Databricks platform. However, I want to do it through the lens of a personal story. In my previous life, I was a busy PhD student, meaning that my home project started and ended with will it fit in the microwave? Needless to say, I was never the type to keep indoor plants. Maybe I would have a succulent here or there on the windowsill that miraculously survived. However, when I moved into my current place, my friends decided that plants are a great housewarming gift, which they are. I loved how they brightened the place, and I quickly realized, though, that I don't know what to do with plants. I assume that they just need to be watered maybe on a Saturday morning, and then they're beautiful and they do what plants do. However, it turns out that they're way more delicate. They care about sunlight, the humidity, the soil, the environment, the temperature in which they grow. However, the worst part is that I only discovered this after accidentally sending a couple of them to plant heaven. Yikes. But that was not the end of it. As a recovering PhD student, my response to this problem was to let's do some research and build a solution. I mean, I wrote a dissertation, I built some experiments, I know what I'm doing, right? But anyways, I put in the tinkering hat, got a bunch of sensors, bought some electronics, rigged everything to a microcontroller, and at the end I ended up with a system that was able to take care of my plants automatically. But that's when I realized that I was gathering a bunch of data from my sensors, and that data, it is gold. It allowed me to track patterns, maybe and do some analysis in order to spot which corner of my house gets the best sun, and even predict when my plant needs some water. So I went a step further, and I've integrated everything to Databricks. In other words, I'm sending live all of this data that is gathering from all of the sensors in my house directly to Databricks in order to do analytics. And this is the story that I want to talk to you about today. So let's start with the actual setup. What you're seeing here is what I call my Raspberry Pi ecosystem. You don't have to understand all of the electronics, that's not the point of this, but the main idea is that I have a bunch of sensors. I have some humidity sensors, I have some air temperature sensor, pressure sensors, soil moisture sensors, and all of them are collecting data. This data is sent to a Raspberry Pi board. This is the point where all of this data is being collected and all of the decisions about what to do based on certain scenarios is being made. However, this is not where the data ends. Outside of the Raspberry Pi ecosystem, I have a Kafka server running within my network. And every single time the Raspberry Pi receives a measurement, it sends it to the Kafka server. The communication actually works both ways. I can send messages to the Kafka server from the Raspberry Pi ecosystem, and also I can read Kafka messages that are intended to be sent back into the Raspberry Pi ecosystem. You can think of Kafka brokers as super efficient post offices for data. They are great at handling loads of information from a bunch of data sources. So given that I am working with a bunch of sensors and IoT devices, they are great because they can handle tons of messages at once, and they move this data very fast, keeping things up to date. In your architecture, these Kafka brokers can be replaced by more traditional databases, think data warehouses. In my case, the role of the Kafka broker is to move data from on-prem all the way to Databricks in the cloud. Databricks offers you the possibility to ingest all of the data from your Kafka server in a very simple way. You might be already familiar with notebooks that allow you to connect to these Kafka brokers and ingest data in real time. At this point, you basically have a bunch of raw data coming from the sensor through the Kafka broker directly into your cloud storage. And this is just the first step of the bigger picture. We have to worry about the quality of the data itself. The raw data is useful, however, we want to extract valuable information and make decisions based on valuable data. And this is the process of using tools like ETL or ELT to take this raw data, transform it, clean it, and make it into those gold nuggets of truth that are being used for decision making. Before we go into the ETLing, we have to talk a little bit about what we call the medallion architecture. As the name might suggest, medallion architecture has a layered type of organization. You have your bronze layer, you have your silver layer, and you have your gold layer. Now, you're not just limited to these 3 layers, but it illustrates a clear separation between your layers. You might have a platinum layer, maybe you might have a landing zone. That depends on your architecture. For this exercise, we will just focus on the basic 3 layers, bronze, silver, and gold. And the whole idea is that bronze is the place where your data is being stored in its rawest form. Now, this data needs to be cleaned, to be improved, we need to apply a schema for it, needs to be standardized, in other words. This is the first step of the ETL process, taking the ingested data from bronze and moving it to silver. Once your data is in the silver layer, it becomes more useful. However, we can perform more operations in order to make it even more valuable. Think about operations like filtering, joining multiple tables together. In other words, we take a more complex, more business logic type of operations and we apply it to the silver data in order to extract the most value out of the data and put it in the gold layer. So now we have created a tiered data architecture, the medallion architecture, that will automatically take the data from your local environment to bronze, apply ETL processing, and move it to gold, from where everyone can use it and extract value. Databricks offers you great tools in order to perform this type of operations. You might be familiar with Delta Life tables already, which offer you a simplified way of building ETL pipelines in a declarative manner. What do I mean by declarative? You don't have to worry about technical things that a data engineer would normally worry about, making sure that the transformation is complete, making sure that everything syncs together. All of that is being abstracted in this Delta Life table framework. And as a creator, you only have to declare the logic of your transformations. Delta Life tables are useful tools to creating your ETL pipelines. But since we are at Databricks, we don't stop here. We always like to innovate. So keep an eye out for an upgrade to our ETL and orchestration framework under the name of Lakeflow. But for now, what you're seeing here is a scheduled Delta Life table where I'm ingesting the data from the Kafka server, saving the raw data into the bronze layer, applying a schema and some cleanup logic to move this data to the silver layer. And from there, I'm actually creating 3 different tables. One table describes the sensor readings from the plants, the moisture of the soils from each plant that I have. Another one describes the environment, think temperature, pressure, air humidity, light percentage. And finally, I have a third table, which actually monitors the statistics of the sensors themselves. One thing that I have not told you yet is that one reading from each sensor is actually a combination of 50 sequential measurements. So what you're actually receiving is the average data with some statistics: mean, standard deviation, median, minimum value, maximum value. And this type of statistics allow me to also monitor the state of the sensors themselves. Information that would be useful later on in order to keep track of the quality of those sensors. As time passes, sensors degrade, they need to be replaced. So now I also have a table that will tell me how all of these statistics are behaving over time. In Databricks, all of the data, along with all of the metadata, is being stored and is being organized in Unity Catalog. Now, Unity Catalog provides you with the organizational aspect. It also provides you with an end-to-end visibility in terms of how your data is being transformed, that is the lineage, but it also allows you to govern your data. In other words, it ensures that the right people have the right type of access to the right type of data. Now that we have all of our data in the medallion architecture stored and governed by Unity Catalog, let's start talking about data personas. In my case, since I'm dealing with sensors and also data about my plants, I can think of two different personas. One persona would be the equivalent of a data analyst who would be interested in seeing how the plants are behaving over time. Do they have enough water? Do they get enough light? Is the temperature okay? And so on. This persona would be interested in the first two tables that I mentioned from the gold layer, the environment and the soil moisture tables. Another type of persona would be the equivalent of an engineer, a maintenance engineer, who is interested in seeing how the actual electronics are behaving over time. For that persona, the relevant table would be the FIR table that describes the statistics of the measurements over time. So to use the governance aspect of Unity Catalog, we can implement something a little bit more tangible and make use of another piece of technology, RFID. Let's imagine this hypothetical scenario where this plant watering and monitoring operation is at a larger scale than my house. So you have a bunch of machines doing a bunch of stuff, and then at a specific location you have a big screen where analyst and also a maintenance engineer can interact with the data. Both of them would have key cards, so all they need to do is scan their key card at the RFID sensor. The key card would encode details about their usernames, and through Unity Catalog, they will be able to access the right type of data. Just to illustrate this example, let's look at each persona in particular. The data analyst will have access to a certain dashboard that will describe the environment and the plants, and they will be able to take advantage of the AI BI part of our platform, where you would have your dashboards, where you have your graphs, you would have your filters, and so on. And data in those dashboards is always going to be current due to the live streaming nature of the Kafka server and the Delta Live tables. On the other hand, the maintenance engineer, if I'm putting the other hat on, would be interested in more in the behavior of the sensors. So they would be able to look into a different dashboard. They would see a different type of data. And in the same manner, taking advantage of the AI BI product within Databricks, they will be able to interact with dashboards and also just ask questions in plain English of the data that's available for them. That's the AI part of the BI product. But this is not all. We have created the medallion architecture. We have created some dashboard for monitoring and interacting with the data and extracting meaningful insights. But there is a missing piece, and that is the end user. It is not very useful for the end user to interact with dashboards. So for that, we would need to create a more user-friendly experience. And that's where Databricks Apps comes into play. Databricks Apps is a new product that is offered on our platform where you, as a developer, have a seamless experience to develop your apps and serve them on Databricks. The beauty of doing this on Databricks is the integration with your data sources. So in other words, besides the experience of the app itself, you also have simple access to the data that is already stored in Unity Catalog. To illustrate this, I have created a simple website with all my plants where I can see the soil moisture levels over the past week and also monitor the environmental conditions. Building apps allows you for further functionality. A particular feature that I have implemented is the backwards communication with the Raspberry Pi ecosystem. In other words, I have added a couple of buttons to each plant on this website, whose role is to send a particular message back to the Kafka broker that will trigger the watering cycle. And this is exactly what happens when you press on one. The message associated with the relevant plant gets sent back to the Kafka server. The Kafka server sends it to the Raspberry Pi. The Raspberry Pi triggers the watering cycle. Each plant has a low level and a high level threshold for the soil moisture, which ensures that we're not overwatering the plants. So let's recap. We started with a local environment where a bunch of sensors are producing data. This data is being fed into a Kafka broker. From that point, via a Databricks notebook, we are consuming this raw data into the bronze layer and taking advantage of Delta Live tables. We are creating the ETL layer within the medallion architecture framework. That's moving data from bronze to silver to gold, where we do some cleanup and we do augmentation. All of this data is kept in Unity Catalog, which provides you with end-to-end visibility in your transformation via the lineage functionality, but also gives you the possibility to govern the entire Databricks environment to make sure that the right people have the right type of access to the right type of data. Now that we have curated data in our gold layer, we are able to build dashboards and interact with our data, and also take advantage of new features within the Databricks platform, and have built an interactive application where an end user can have a clean user interface and keep track of their plants and the environments in which these plants are growing happily.